Hi guys, my name is Himalay Rathod and my partner's name is Pamula, and we'll be doing a presentation on D programming language. What is D? D is a general purpose system and applications programming language. It's a high level programming language, but it still retains the ability to write high performance code and interface directly with the operating system, API, and hardware. D is suitable for writing medium to large scale million line programs with teams of developers. It's easy to learn, provides many capabilities to aid the programmer, and it's well suited to aggressive compiler optimization technology. D is not a scripting language, nor an interpreted language. It doesn't come with a VM, a religion, or an overriding philosophy. It's a practical language for practical programmers who need to get the job done quickly, reliably, and leave behind maintainability. And it's easy to understand code. All right, so a brief history of D. D is a programming language, and it was created by Walter Bright of Digital Mars and released in 2001. Bright joined in the design and development effort in 2006 by Andrei Alexandrikis. Though it originated as a re-engineering of C++, D is a distinct language, having redesigned some core C++ features and still taking inspiration from other languages like Java, Python, Ruby, and C Sharp.
So the question is, why D? Who needs another programming language? Well, the software industry has come a long way since the C language was invented. Many new concepts were added to the language with C++, but backwards compatibility with C was maintained, including compatibility with nearly all the weaknesses of the original design. There have been many attempts to fix those weaknesses, but the compatibility issue frustrates it. Meanwhile, both C and C++ undergo a constant creation of new features. These new features must be carefully fitted into the existing structure without requiring rewriting old code. C++ implements things like resizable arrays and sorting concatenation as part of the standard library, not as part of the core language. The general look of D is like C and C++. This makes it easier to learn and port code to D. Transitioning from C to D should feel natural. The programmer will not have to learn an entirely new way of doing things. The general look and feel of C is maintained. It uses the same algebraic syntax, most of the same expression and statement forms, and the general layout. D programs can be written either in C-style function and data, C++ style object-oriented, C++ style template metaprogramming, or any mix of the three. There are many features of D language. We're going to talk about the major features of D language, which are object-oriented programming, functional programming, productivity, and ranges. In object-oriented programming, comes with classes and operator overloading. Classes can be crafted that work with existing operators to extend the type system to support new types. An example would be creating a big number class and then overloading the plus sign, negative sign, multiply, and divide sign operators to enable using ordinary algebraic syntax with them. Of course, this object-oriented nature comes from classes. The inheritance model is single inheritance enhanced with interfaces. The class object sits at the root of the inheritance hierarchy. So all classes implement a common set of functionality. Classes are instantiated by reference, and so complex code to clean up after exceptions is not required. D allows writing large code fragments without redundantly specifying types, like dynamic languages do. On the other hand, static inference deduces types and other code properties, giving the best of both the static and the dynamic worlds. Automatic memory management makes for safe, simple, and robust code. D also supports scoped resource management and scoped statements for deterministic transactional code that is easy to write and read. Built-in linear and associative arrays, slices, and ranges make daily programming simple and pleasant for tasks, both small and large.
Cool.
The best paradigm is to not impose something at an expense of others. D offers classic polymorphism, value semantics, functional style, generics, generative programming, contract programming, and much, much more, all harmoniously integrated. D offers an innovative approach to concurrency, featuring true immutable data, message passing, no sharing by default, and controlled mutable sharing across threads. From simple scripts to large projects, D has the breadth to scale with any application's needs. Unit testing, informational hiding, refined modularity, fast compilation, precise interfaces.
D compiles naturally to efficient native code. D is designed such that running simple code is fast and safe. On some occasions, a function might need to escape the type safety for more speed and control. D also offers native pointers, typecasting, access to some C functions without intervening with translation for more efficiency. So, why haven't we heard of D language? Obviously, it's efficient and it's very simple to use, but it's not popular in the field. There are a couple of reasons for that. One of the reasons is that it has a large runtime library, which means it costs a lot of money for corporations, which they don't want. And these creators, Digital Mars, aren't really big players in the corporate world. And their target audience was originally Java and C++ programmers. With large corporations like Microsoft, they're always pushing programmers to use C Sharp, and they target the same programmers, which is why most of them don't really use D. Instead, they use other big programming languages like C and C++, Java, and much more. Alright everyone, I'll show you how to write a simple program in D. The first thing you do is you're going to be importing your libraries. It's quite simple, just like you do in C. You'd use stdio and string, just like over here. Instead of using include, we're going to be using import. Inside your main, if you want to print out a line, you could use write. Over here, we're using write. Please enter some text. And if you want to read an input from the user, you use read ln, and it will store it right into input. Notice that over here we use auto. Auto automatically defines the type for you. In our case, it will be a string, and you don't need to worry about typecasting. It does that for you over here. And we're gonna have a simple if-else statement. If input is empty, you're going to print out you didn't enter any text, and else you're going to print out you entered and whatever the input was, and that will be our simple input output. Let's say if you had an array in large amounts of numbers, you could simply just do int and then just put the brackets over here and the name of the array. We're just gonna call it array, and it's gonna be 1 through 9. You don't need to define how long the array is gonna be. You let the compiler deal with that. You let the compiler deal with the memory management for the array also. All you gotta do is define that it's gonna be an array and just put in all the elements inside the array. And if you want to print that out, it's quite easy. You'd use a for each loop like we learned in class. So it's going to be for each item. So our item is going to be I inside items. So that's going to be our array. Also, another thing to mention is that over here, you don't need to put auto. You let the compiler deal with that. All you got to do is put the variable for item and put the variable for items. So for each item inside items, you're going to be printing out the each item. And that's your simple for each loop. And that concludes my demo for today. Thank you for watching.